Learning target 1 is called recognizing factoring techniques, and what that means is we don't really have to solve the problem, we just have to name what it is based on what it looks like. If you read the instructions, it doesn't say we have to work our way from 1 down to 7. We can do these problems in any order we want, but the instructions do say you may use an answer more than once, so there is possibly going to be a repeat answer here. Now, if I was doing this, I would kind of work backwards, and I would start with grouping. No matter, even if grouping wasn't A, I'd always start with grouping because grouping is the only one that has 4 terms. So that should be pretty easy to identify. So number 4 is going to be grouping because that's the only one that's got 4 terms on. Now GCF, I would actually save that one for last because GCF doesn't really have any characteristics. It could have 2 terms, 3 terms, 4 terms, and so on. So I'll save that one for last. The next one I would do is simple or complex ABC because both of these have 3 terms. And I'm looking through the problems, and number 1 has 3 terms, number 2 has 3 terms, and number 7 has 3 terms. So starting with number 1, this one has 3 terms, but it does have a number in the front other than 1. So that's going to make it a complex ABC. So that's D. Number 2, that has 3 terms, and this one has a 1 in front. So that's going to make it a simple ABC. So that's C. And then number 7's got 3 terms, and that one also has a 1 in front. So that's also going to be a simple ABC. So that's our repeat answer right there. Now the next two, they have 2 terms each. Now since they're both different, that means that they're going to have a minus in the middle, but one has to be a squares and one has to be a cube. So I'm going to start with the squares first. So if I look at number 3, it has the minus in the middle, it's got 2 terms, and if it's a perfect square, I should be able to square root that term. The problem is x to the 9th cannot be square rooted, so that's not going to be the squares problem. So if I move on to number 5, I try to square root the 34. If you type that in the calculator, it gives you square root 34, which means it's a decimal, so that's not it either. You square root 36, that's 6. Square root of 25 is 5, and then the square root of x squared is just x. So that is going to be a difference of squares. Now, a cubes question is very similar, except you have to be able to cube root it. So if I take the cube root of x to the 9, that's going to be x to the 3rd because all you do is divide the exponents. If I take the cube root of 64, that's going to be 4. So that's my cubes problem. If I try to cube root 34 in the calculator, it gives me a decimal. So that's not going to be a cubes problem. So just by process of elimination, number 5 has to be GCF. Now I will kind of explain why it's the GCF. You should be able to divide 34 and 12 because they're both even. So you should be able to divide it by at least 2. And notice also, this one has an x and this one has an x. So that means that it has a GCF that's a letter. So the GCF is usually going to be the lowest exponent when you have letters in every term. So the GCF there would be x squared. Okay, number 8 says, what type of factoring was done to go from the original expression to step 1? So from the original to step 1, the first thing I noticed is now all of a sudden it has parentheses, but more importantly, it's got that number in the front. Anytime you take out a number and put it in the front, that's called the GCF. Now, in my class, when we talked about the GCF comes out to the front and it kind of just follows you till the end. So we were calling that the Chucky number or the Chucky term. Because if you've ever seen the movie, he's friends till the end. So that's kind of how we remember it in my class. Okay, so now in section 2, we're going to get into the actual factoring. So we need to get the calculator set up for factoring. So in the calculator, you're going to go into your menu and go into your table. And you want to set your table because you never know who's been using your calculator. I've got 5 other classes. And so they could change the settings on you. So if you had this straight out of the package, it goes from 1 to 5, and 5 is going to be way too small. So what I like to do is I like to go into my calculator and I like to make that number much bigger. So I'm going to head over to the table. I'm going to go into F5, which is to set the table, and I'm just going to make it huge. I'm going to make it 100. I mean, 100 is not that big, but it's going to be big enough for the problems that we're going to look at. Okay, so now our calculator is going to be ready for factoring. The other thing we're going to want to probably get the calculator ready for is to find the GCF for us. The first step of every problem should be to calculate the GCF if it has one. So to get to the GCF, it's a lot of buttons. You're going to be in the regular calculator mode for this. So if I go into my menu, I can head over to Run Math and enter. And then we're going to have to hit a series of buttons. It's going to be Option, F6, F4, F6, and then F2. So I'm going to demonstrate that. So we'll hit Option, F6, F4, F6, and F2. So that's how we calculate the GCF. Now, keep in mind, when we calculate GCFs on the calculator, we cannot use letters. It's going to be numbers only, okay? When we type them into the calculator, we're also going to always separate the terms using the comma button. So here's our first question. This one has two terms, so I should probably check to see if it has a GCF. So I'll check GCF between 24 and 16, and we don't have to put the minus in there. So the GCF between 24 and 16 is going to be 8, so we should be able to take out an 8. Now you should also notice that each term has x's in it. So anytime they all have x's, you take out the lowest exponent. I don't know why I traced a 5. It's going to be x squared for that. So I'm going to go ahead and put an x squared at the bottom as well. So the GCF is the stuff that we're going to divide out. So that goes in front, and that becomes our Chucky term out in front. And then we're going to have a parentheses here, and we're just going to divide what's left. So 24 divided by 8 is 3. X squared divided by x squared cancels because it's 1, so you don't need it anymore. And plus, you took out 2 of the x's, so they're out here in the front now. So this doesn't have any x's left. And we have 16 divided by 8 is 2. And if I have 5 x's and I'm taking out 2 of them, that's going to leave me with 3. So the extra 2 came out to the front. So this is our final answer. Keep in mind, this is single step factoring. So once we factor one thing, we're done. Next one, it's got a 16u and a 16u squared and a 250u. So right away, I see that it has a u and a u squared and a u. So I'm going to check the numbers in the calculator. So GCD, which is the same as GCF, we're going to type in 16. Oops, I missed the 6. 16, comma, 250. So that's just going to be 2. So I have to divide this by 2. And then I have a u squared and a u. So this u has a 1 on it. So I'm going to have to just take out a single u. So 2u goes in the front. 16 divided by 2 is 8. If I have u squared and I take out one of the u's, that just leaves me with a single u. And then 250 divided by 2 is 125. And then for these u's, I have one u up on top, and I'm taking out one of the u's, so it doesn't have any u's left because that u is out in front now. And that's our answer. Okay, this one here, this one has the ABC pattern, and it's a simple ABC. So when we have a simple ABC, all we have to do is type stuff into the calculator in the table, and I kind of have stuff there so I can write on it because I can't write on the calculator. So I'm going to head over to the table now. And the cool thing about this table is it works on every ABC question. So we always type in the last number. So we're going to type -4 divided by x. That'll always be the first one that we type in. And then we're going to do it again, -4 divided by x. But this time we're going to do a plus x. Plus x. So we go into our table. If you see that black thing up in the right corner, it means it's working. Now, I can't write on the calculator, so that's why I had it ready to go over here. What we're going to do is we're always going to search this last column, and we're going to try to find the middle number. The middle number in this problem is a -3. So you can see that I do have the -3 here, and so that means that these two are the factors we need to use in the parentheses. If this is an x squared, I'm just going to kind of cut it in half, and I'm going to put one of the x's here and one of the x's here. And then I just use the terms that are inside on this right here. So I'm going to put +1, and I'm going to put -4. Now this right here is a simple ABC, which means there's no more other work that we have to do, no extra work. So that's going to be our answer. Number 12. Number 12 is going to be a complex ABC. Now, when we have a complex ABC, we're going to have to adjust it by multiplying the first term and absorbing it into the last term. So that's going to make it a -40. So now this is just a regular 8x squared, or just x squared minus 6x. Now we don't want to forget about this 8 because we're going to have to take it out at the very, very end. So again, in the calculator, here's how that would look. So on the top, we're going to have a negative 40 instead. Now I'll go up to the first one and change that to a negative 40. And then I hit execute. And I'm going to be looking for the middle number. So I'm going to be searching for a negative 6 in that third column. So looking here, I can see that I have the negative 6 right here. And so these are the actual terms that I'm going to put into the parentheses, but we're not quite done yet because this is a complex ABC. Complex means we're going to have one extra step. So I'm going to put x in one parentheses, x in the other parentheses. Since the sign matches, I don't have to make any adjustments because this is a minus 6 also. So I'm going to use a positive 4 in the first parentheses and a negative 10 in the second parentheses. Now, that 8 from the very beginning needs to come out. So I need to divide this by 8 and divide this by 8. Now, we should always try to simplify our fractions if possible. So this is going to give me 1/2. And this one right here is going to give me 5/4. If you don't know how to reduce a fraction, you can just go do that in your calculator and use the ABC button. Now, neither of them divided evenly, so that means that the bottoms have to move up to the front of the x. We call that move bottoms up. So this is going to be 2x plus 1. And this other one, if I move the bottom up to the front of this x, is going to be 4x minus 5. And that's our answer. So a complex ABC has that last step, and we call that step bottoms up. We always divide out that front term that we absorbed into that last term. Okay, this next one, notice how it only has 2 terms. This looks like it's going to be a difference of squares. The reason why I know that is because I can take the square root of 49 and a squared. That's just going to be 7a. If I take the square root of 100, that's going to be 10. Now the pattern for these is when you have a difference of squares, what's going to end up happening is you're going to simply make a copy of it. So it's going to be the same stuff on the inside. And the only thing that's going to be different is one's a plus and one's a minus. That's our answer. One thing that we talked about in class is the order doesn't matter. So as long as you have one parentheses that says 7a plus 10 and the other one says 7a minus 10, doesn't matter how you write it. You can also write 7a minus 10 and 7a plus 10, and it's the same thing. Okay, next question. It looks like it's going to be another difference of squares. And the reason why I kind of know it's going to be that is because of this 2 right here. So that's a big hint. So square root of 64 is 8. The square root of h squared is h. Square root of 1, notice how I also square root. I don't put the negative inside there because you can't. So that's going to just give me 1. So the pattern for this is write it again. And then 1's a plus and 1's a minus. Okay, number 15. Number 15 has a cube, so this is going to be a cubes problem. Now, a cubes problem is a little different. We're going to have to cube root everything, so that's going to be 3x. And then we have a cube root of 1 is just going to give us 1. Now, the way this works is this one's going to be a much bigger answer over here on the right. It's going to have 3 terms. Now, the way you build those 3 terms is from these first 2. So if this is the a spot and this is the b spot, this next spot would just be a times a. So 3x times 3x would give us 9x squared. The middle spot is a times b. So a times b would be 3x times 1, so that's 3x. And then that last spot would just be b times b. 1 times 1 is 1. Now we have an acronym to try to remember how the signs go. The acronym is SOAP. So it's going to be S-O-A-P. S stands for the same, so it's going to be the same as the problem. O stands for the opposite, and then AP just means that it's always going to be a plus. The reason why that's always a plus is because it comes from the b being squared. So no matter what the sign is, it'll always end up being a positive. And that's our answer. I want to show that to you again. I can tell this one is going to be a cubes problem because it's got the 3 on it. So if I cube root all of this stuff, it gives me 10r for the first spot. And if I cube root this right here, that's going to give me a 3 for the second spot. So this is spot A and spot B. And we're going to have the bigger parentheses over here. So it'd be A times A times B, and then B times B. So a times a would be 10r times 10r, so that's 10r squared. A times b would be 10r times 3, so that's 30r. And then b times b would be 3 times 3, so that's 9. Then our SOAP acronym, SOAP. So it's going to be same as the original, so that's going to be a minus, opposite, and then always positive, and that's our answer. Okay, next one is grouping. So a grouping question, you kind of just break it up into the first two and the last two, and then you're going to take out the GCF. So I should have my calculator ready to go if I just head over to, pull that back up. I don't know why that happened. I'm going to head over to run math. So I'm going to have to hit the 5 buttons again, or you could just go up. I'll go up and change them. Too lazy to find the button. So it's going to be 18 and 2. So 18 comma 2. And the GCF is just 2. So we're going to take out a 2 from this one and a 2 from this one. Now, typically in this first group, you're always going to take out some letters also. So I notice it has x to the third and x squared. So this is going to be x squared because we always go with the lowest. So that's going to come out to the front. That's our Chucky number or Chucky term that we talked about. So this is going to give us 9x minus 1. And I do the same thing for the other side. So I'm going to take the GCF between 27 and 3. So let me head over to the calculator and I'll just pop up to here. Delete that and I'll put in 27 comma 3. So the GCF is going to be 3. A lot of times it's just going to be a number in this second set because you can see that this only has an x and the second one doesn't. So I'm going to put that 3 out in the front. And then when I divide this, I'm going to end up with 9x minus 1. Now you can see, like, I'm trying to color code this so you can see, like, at this step, you should be able to tell if you're doing it right. By definition, if they both have it, that's considered to be a GCF. So since these both have the 9x plus 1 or 9x minus 1 in the parentheses, GCFs typically get pulled out to the front. So I'm going to take 9x minus 1, put that in the front. And then I'm going to create my second set with the original GCF of each part of this problem. So the 2x squared plus 3 is going to create its own set of parentheses. Now, like I said before, the order doesn't matter. So the red one can go first and the blue one can go second. And it's the same answer because multiplication, order doesn't really matter. If I do 5 times 2, it's going to be the same as 2 times 5. Okay, we've got another one here. So I'm going to split it up. I'm going to take out the GCF of the first set. Now I'm looking here at the numbers, and this has a 1, so it's just going to be 1. But it also has an a squared and a to the third, so we take out the lower one. And I'm not writing the 1 at the bottom because when you divide by 1, it doesn't really do anything. So I'm going to put the a squared there. This is going to be 2a because if I have 3 a's here and take out 2 of them, I'm left with just 1. And then this guy right here is just going to be minus 1. So then the second set, between 4 and 2, it's going to be 2. And you can double check that in the calculator if you're not sure. So it's going to be a plus 2 here. And then the second set of parentheses is going to say 2a minus 1. So we can see right here at this step, we are on the right track because these should match right here. So since these are the same, I pull them out to the front. And then the original GCFs, they create the second set of parentheses. And as I mentioned before, order doesn't matter. If you want, you could have wrote the blue one in the front and the green one at the back end, but that's the answer. Okay, multi-step factoring. This one is huge. When you see competency 3, multi-step factoring usually means there's going to be a GCF. So we have to make sure we check if there's a GCF in every single one of these questions. So starting at number 19, I'm going to pull out my calculator. I'm going to go ahead and just go to the GCF button here in the calculator. I need to have that ready because I need to check all of these problems for the GCF. Now, when we check the GCF, we don't need to type in any negatives. So I'm going to just type in 3, 3, and 90. And this is going to be a 3. However, we don't really want to have negatives in the front of our problem. So in addition to just taking out the 3, I'm going to go ahead and make it a negative 3. So this is our Chucky term out in front. And now the problem is going to change a little bit. And that's just step 1. So the GCF is step 1, and this is called multi-step factoring. So there's going to be more that we have to do after. So I'm going to have b squared, I'm going to have minus b, and then I'm going to have minus 30. So at this point, now we're going to have to factor it. It looks like it turned the blue problem into a simple ABC. So I'm going to go ahead and head over to the table, and I'm going to type in negative 30 divided by x, and then negative 30 divided by x plus x. And that's, again, that's the pattern on every single ABC problem that there is. It's always the number divided by x and then the number divided by x plus x. So in my table, this is what I've got, but I think I set this up so I have it over here. So you scroll down, remember that we always search, we're always going to be searching this third column here. So that third column, we're looking for the middle number, and that middle number is a 1, a negative 1. So we have the sign, so that's good. So we're going to go ahead and use these in the parentheses. So we'll put b plus 5 in one parentheses, and then b minus 6 in the other parentheses. And then this guy's got to follow us till the end, and that's our final answer. Now, I didn't have to divide this because the new problem has a 1 in front. And even if you did, if you divide by 1, it doesn't change anything. So you'll still end up with the same answer. Okay, next question. We've got 6. There's another ABC question. So this is going to be a lot of calculator work. So let me go back. We're going to put in, now this one is a complex ABC. So before I type anything in the calculator, I need to absorb this 6 into this 9. So 9 times 6 ends up being 54. So this is going to be our new problem. So it's p squared plus 15p, and then we have this positive 54. So in our calculator, we're going to go ahead and put in 54 divided by x. And the second one is going to be 54 divided by x plus x. So remember, every ABC problem is pretty much done the same when you get to the calculator part of it. So I'm going to let it work for a second, and I'm going to go search for my 15. Okay, yeah, scroll down. So there's my 15. So that means I have to use 6 and 9 in the parentheses. So I'm going to go ahead and put p. Actually, you know what? I forgot. This is multi-step. I got to take out the GCF. Remember, I said that in the very beginning. So this has a GCF. Got all excited. Let me go back real quick, and I'm going to head over to Run Math so I can go into my GCF button. So I'm going to hit those 5 buttons again. So Option, F6, F4, F6, F2. So I need to do 6, comma, 15, comma, 9. I almost forgot my own rule here. Multi-step factoring is usually going to have a GCF. So this is going to have a GCF of 3, and that's our Chucky. Little Chucky term out in the front. So this is going to be 2p plus 5p, and this is p squared, by the way, and then plus 3. Now, this is still a complex ABC, so we're going to have to multiply the 2 with the 3 and absorb it into that. So that's going to be a plus 6. So now this is p squared plus 5p in parentheses. And then don't forget Chucky. He's going to follow us till the end. So now in the calculator, here's what we're doing. We're going to go back into the table, and we're going to do 6 divided by x. And we're going to do 6 divided by x plus x. So in this, we're going to go search for our 5. And there's 2 5s, but it doesn't matter because if you notice the numbers next to it, they're both the same. So if I go here, I think I have it ready. So I'm going to go ahead and put this into the parentheses, p plus 2 and p plus 3. We've got our Chucky in the front. Now, our problem at this step had a 2 that we absorbed into the 3. So I'm going to need to take that out now. So I'm going to divide that by 2 and divide that by 2. So our final answer is going to be p plus 1. Now 3 can't go into 2, or 2 can't go into 3 evenly, so I'm going to take this 2 and move it up in front. So that's going to be 2p plus 3. And then our Chucky term follows us till the end, and that's our answer. Okay, I got to remind myself, multi-step means GCF. So this is definitely going to have a GCF. So let me go to my calculator, go into the menu, head over to Run Math, and then Option, F6, F4, F6, F2. So we're going to stick in 5, comma, 20. Remember, we can't put letters in the calculator, so the GCF for the numbers is going to be 5. And then when you look at the x's, we're going to go with the lowest one every time, so it's just going to be x. So this is 5x in the front. Now we're going to create a new problem that's going to have another step to do. So this is x squared minus 4. Now, if you notice, this isn't a simple ABC anymore, so it's going to be one of our special binomials. Looks like it's probably going to be a squares problem because I can square root this and square root this. So in the parentheses, we'll have an x and a 2, which in this type of problem means we'll have an x and a 2 in the second one. One will be a plus, one will be a minus, and then our GCF, our Chucky term, follows till the end. Okay, next one, GCF. Looks like we have a GCF between 2 and 54, so 2, comma 54. It's going to just be 2. And then we have to check the letters ourselves. So m squared is lower, so we're going to go with m squared. So I have 2m squared in the front. That's our Chucky term. And now this is going to be left with m to the third minus, if we do 54 divided by 2, 54, I don't know why my 5 is not working, 54 divided by 2, that gives us 27. So this, again, is a multi-step. We took out the GCF, but now we have to factor again. So this is going to be a cubes problem. So I have to cube root this and cube root this. So it's going to give me an m and a 3. Notice I don't put the signs because we'll use SOAP later. So following the pattern, this is A, this is B. So this would be A times A times B, and then B times B. So m times m is m squared. M times 3 is 3m. And then 3 times 3 is 9. So SOAP would be same. So that's going to be a minus. Opposite, and then always positive. And then we have to bring down our Chucky term because he follows us till the end. Hope whoever makes these movies with Chucky in them don't come after me for saying this in my videos. Anyways, okay, next one. GCF. Don't forget, multi-step is usually going to have a GCF. So I'm going to go GCF between 32, comma 4. That's going to be a 4. Now notice in this one, we don't have any letters on this term over here, so I can't take out any letters on this one. So I'm going to put the 4 in the front. That's our Chucky term. So this is going to be 8x to the third and minus 1. Now this, again, it's multi-step, so we're going to have to factor this now. That's a cubes problem. So cube root that, that's 2x, and then cube root that, and that's 1. Pattern is spot A and spot B, so this is A times B, and then B times B. So A times A would be 2x times 2x, so that's 4x squared. A times B would be 2x times 1, so that's going to be 2x. And then 1 times 1 is just 1. And now we can use the SOAP acronym, SOAP. Same as the original, opposite, and then always positive, and then we got to bring down our Chucky term. So this is our answer right here. Okay, let's see, next one. Got a GCF between 16 and 54, I'm sure. Oops, I have to hit GCF first. 16, comma, 54. So that's going to be 2. And now these both have letters, so I'm going to take out the lower exponent. So 2b squared is our Chucky term. So that leaves us with 8b to the third plus 27. So you can tell already, because it's got this 3 in it, it's going to be a cubes. So we're going to cube root and cube root. So that's going to be 2b and 3 in the first parentheses, and then we follow the pattern. So the next parentheses is going to be A times B, and then B times B. So 2b times 2b is 4b squared. 2b times 3 is 6b. And then 3 times 3 is 9. So now for the SOAP acronym, SOAP. Same as the original, opposite, and then always positive. And then we got to bring down our Chucky term, 2b squared. So that right there is our answer.